Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, we are going to take another fresh and interesting topic, that is linear inequalities. And what we are going to discuss the first is how to solve the linear inequality. So let's begin. After completing the very lesson today, my dear student will be able to find the solution of a given linear inequality, and the number two also be able to represent that very solution of the linear inequality on a number line. This is what I hope you'll be able to do after completing the very lesson today. My dear student, as usual in a favorite segment of the lesson, Mercy Fun, today I'll give you another interesting number. This number is 69. It's so special, so amazing, so unique. I'll tell you what is special about this very number 69 after completing my lesson today, so don't go away. To begin the lesson, my dear student, let me just explain the meaning of solving inequality. So solving inequality means finding the value of x or any other variable that you have there in the given inequality, so that that inequality becomes a true inequality. And let us just quickly move and learn how to find the solution. So let us learn the rule. The rule says the same rule for solving simple linear equation is the same rule that we are going to apply, or the same rule that we are going to adopt while solving linear inequality, but it says with only one exception. It's only one place that they differ. All that we did in solving simple linear equation, that collectively like terms dividing both sides, but whatever we did in attempting to solve the simple linear equations is the same process also, but with only one exception. Let us see the exception. It says the exception is happening when you multiply or you divide both sides by a negative number. If that is the case, the inequality sign reverses. What I mean by reverses is if the sign were greater, it will now change it to less than. If the sign were less than, it will now change it to greater. And if the sign were before greater or equals to, it will now change it to less than or equals to. And if the sign originally was less than or equals to, it will now change it to greater or equals to. This is the meaning of sign will now reverses. So after dividing both sides by a negative number, or after multiplying both sides by a negative number, your inequality sign will now change, which we shall see in the example. So these are the steps that we have to take in order to solve inequality successfully. So let us just move and take examples. Example number one, it says solve the inequality 3x minus 1 greater than 5x plus 9. This is the given inequality asked to solve. Solution to this very problem. Remember, the rule says is the same we did to solve the simple equation is the same we also adopt here. So let me just copy my inequality. If this were equation, what I would think do is to collect like terms. All those in x, let them be by one side. Those that don't have x, let them be by the other side. So let me collect like terms. In collecting like terms, what I'm going to do, this 5x will now be shifted to the left, and this minus 1 will now shift it to the right. So I'm going to have 3x minus 5x greater than 9 plus 1. So I'll now collect like terms. So 3x minus 5x will give you minus 2x, and 9 plus 1, you have 10 as your answer. So next, we now divide both sides by the coefficient of x, which you can see here is minus 2. So remember, the rule says it's only here that they differ slightly. So when you divide both sides by this negative 2, this inequality from greater, it will now change it to less than. Let me do that. So I'm going to have minus 2x divided by minus 2. You can see the sign of greater now becomes sign of less than. So I have 10 over minus 2. So this minus 2 cancel minus 2, will be left with x, and 10 divided by minus 2 gives you minus 5. And this is the solution to this very inequality. Let's just move and take another example. Example number 2, it says solve the x plus 2 greater or equals to 3x minus 5 and sketch the solution on a number line. So solution to this very problem, what I'll do first is to copy my given inequality. So x plus 2 greater or equals to 3x minus 5. So what I will do first is to collect the like terms. So there I have 3x shifted to the left and plus 2 shifted to the right. So there I have x minus 3x greater or equals to minus 5 minus 2. I'll continue. X minus 3x will give answer minus 2x greater or equals to minus 5 minus 2 give this result minus 7. So I'll now divide both sides by this minus 2 again. And dividing this by minus 2 to the inequality from this greater or equals to, it will now change to less than or equals to. Let me do that. So I'm going to have minus 2x divided by minus 2. You can see this symbol of inequality greater or equals to now become less than or equals to, then minus 7 divided by minus 2. Let me do the division. So after the division, you now have by the left, you have x alone, and by the right, you now have 3 whole number 1 over 2. But the question says after solving, we are to sketch the solution on a number line. So I have x less than or equals to 3 whole number 1 over 2. So let me draw my number line. Remember, this is treated in your junior secondary school. So I'll try to find this number, or try to have this number, this 3, and some other numbers beside it. So I'm going to number my number line minus 1, 0, 1, 2, 3, 4, 5, 6. This is what we are just after, some numbers close to 3, both sides of it. So what I'm going to do, this is 3 whole number 1 over 2. So I'll now just estimate if this is 3, this is 4. Somewhere middle will now be 3.5. That is 3 whole number 1 over 2. I'm going to draw a small cycle there. Let me do that. Look at the cycle. Look at the cycle. And next we now do, I'll go back to my solution. It says less than or equals to, less than or equals to. So what I'm going to do, I'm now going to draw an arrowed line to either point left or point right, depend on what is I have here. If this is less than, then I will now draw my arrowed line to the left. To the left, because it is there I have values smaller than what I have here. That is 3 whole number 1 over 2. Let me draw that arrowed line to the left. It is here I have values. All values here by the left of this very point are smaller than the number at that very point. But this inequality is O equals to, O equals to. So to make it different from just strictly less than, what I'm going to do, that small circle that I have drawn, I'm going to shade inside. So let me shade it. All this is done in your junior secondary school. I'm just revising it. So this will now be the solution of this inequality on a number line. I'll now write the solution, that is x less than or equals to 3 whole number 1 over 2. Let me just move and take another example. Example number 3 says, so solve this inequality x over 4 minus 1 less than or equals to x over 2 minus 5. And this also we have to sketch this solution on a number line. So solution to this very problem, copying the given inequality, that is x over 4 minus 1 less than or equals to x over 2 minus 5. So what I need to do first is to clear this fraction. I don't want to work with the fractions. Or fractions always look my work somehow to be a bit complex. So let me just clear these fractions. How I clear it, I will now find the LCM of the denominators 4 and 2. I will now multiply each and every term by that very LCM. So LCM of 4 and 2 will now be 4. So everything times 4. So I'm going to have x over 4 times 4. This minus 1 times 4, x over 2 times 4, this minus 5 times 4. This will now clear my fraction. So after multiplying, I will now have x over 4 times 4. This 4 will cancel, I will have x left. And minus 1 times 4 gives you minus 4. X over 2 times 4, you have 2x as your answer. And minus 5 times 4 gives you minus 20. So there I have reduced this to a simple equation, not having fractions. So I'll now collect like terms. So collecting like terms, I'll now shift 2x from right to the left and shift this minus 4 from left to the right. So there I have x minus 2x less than or equals to minus 20 plus 4. So x minus 2x will give answer minus x, and the minus 20 plus 4 gives answer minus 16. So I'll now divide both sides by -1 here. This is -1, which we don't usually write. So dividing both sides by -1 reverses this inequality to greater or equals to. So let me do that. So there I'm going to have x greater or equals to 16. I have divided -16 by -1, so minus change it to plus. So this is the solution. What remains is to represent this very solution on a number line. So let me draw my number line. I must have this number 16 and some other numbers beside it. So this is my number line. Let me just number it: 14, 15, 16, 17, 18, 19, 20, 21. And what I'm going to do, I'll draw a small cycle on top of that 16. And I'll look at my symbol of inequality. It is greater. So numbers to the right are always bigger than the number here. So let me just draw that arrow, the line to the right. And my inequality is greater or equals to. So to make it different from just strictly greater, what I'm going to do, I'm going to shade this inside the small cycle. Let me shade it. This is it. So when you see shading in this small cycle, it means the inequality O is O equals to. So this is the solution of this very inequality. With this, I have come to the end of this very lesson, my dear student. I hope you find it resourceful. Let me just move to the last segment versus fun and explain what is special about the number 69. If you are to find the square of 69 and also find the cube of 69, if you combine the two results, the results will now contains every digit from 0 to 9, and each digit will appear just once. Let's just find out the square of 69. Square of 69 will give you 4,716 if you did correctly. Let me get the cube of 69. If this is done correctly, you now have 328,509. And what this is seeing in these two results, if you look at the two results and look at the numbers from 0 to 9, these numbers 0 to 9, you all have them in these two results combined together. That is, look at your 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And what is special, all those digits appear each one time, only once. This is really interesting, which I believe you never notice a number in this form. So square of 69 and the cube of 69 together, the two results, when you combine them, you get each and every digit from 0 to 9. Thank you for your attention. We see more of these interesting things in mathematics in our subsequent lessons.